Hi, this is Paul, the SDR-Guy, and we've got an extra exciting session for today. We're going to learn about what GNU Radio Companion is. We're going to learn a little bit about FM modulation. This may be new to some of you, or it may be a review for some of you. Then we're going to build a broadcast FM receiver. We will build the receiver both for mono, and then we will make improvements to make it stereo. We will be using the RTL-SDR, and either the V3 or V4 version should work just fine. So, without further ado, let's get right at it. What is GNU Radio? GNU Radio is a free and open source software development toolkit that's used for implementing software-defined radios, or SDRs. It provides a collection of signal processing blocks that can be combined to build and experiment with radio systems. It's used in various environments, including research, industry, academia, and hobbyists, for both wireless communications research and the development of real-world radio systems. Alternatively, we could say that GNU Radio is a digital signal processing toolkit. Our SDRs will be outputting IQ signals. The I stands for in phase, the Q stands for quadrature. And rather than me explain that in this video, I'm going to refer you to a very good video that explains the basics of this. See the link in the description. What is frequency modulation? Well, basically it is a technique where we encode information onto a carrier radio wave. So when I say information, I could say it could be someone talking, it could be music, and the result is the same. We're encoding this information signal, if you will, into a carrier wave. What I'm going to do next is there is another open source project, open source meaning free, called GNU Octave. And this software is very similar to a commercial software package called MATLAB. And what I'm going to do is I'm going to show you a little script here in GNU Octave that will actually perform a FM modulation. So let's look at the screen here. We want to point out that we have a sampling frequency of 1000. We can skip over the time duration for now. Line number 7, where X equal, what we're doing is basically just adding up 2 sine waves. On the next line, we have a carrier frequency of 200, and this is in hertz. And we have a frequency deviation of 100. So that means that the encoded information can go up to 300 or down to 100. This line 16 is where we're doing an FM modulation. And lastly, we're plotting this out. So we're going to go ahead and run this. And here we go. So the red lines that you see here, you can kind of see the high peaks and the low ones. This is the information that we're encoding onto the carrier, and the carrier plus the information, we see it in blue. And the thing I want you to notice is when the peaks move up to a higher value, the frequency increases, and when the peaks move to a lower value, then the frequency decreases. So we're building an FM receiver, and an FM receiver basically demodulates whatever information is on the carrier. In our case, we will route that to the output in GNU radio, which you'll see in a few minutes, which is essentially the speakers on our PC. Okay, let's go ahead and hook up our antenna to the SDR, and let's plug this in. There you go. And notice I'm just using some rabbit ears that actually came with my SDR. Let's create a simple mono FM receiver. So to begin with, we're going to come down here to search. We're going to search for GNU, and we want GNU Radio Companion, so you can click there. In my case, I have already launched it, and I added it to the taskbar here. So let's open that up. And here we see GNU Radio, and whenever we open up a new Flowgraph, there's automatically two different blocks here. There's one for options, and there's a variable for sample rate. So what we're going to do next is we're going to go and get all the different program blocks that we're going to need. So over here on the right side are all the different program blocks, if you will. And there's a couple of different ways that you can search for these things. One is you can click on the magnifying glass, or you can hit Control, hold the Control key down and hit F. There you go. So the first thing we're going to do is we're going to add 3 Qt GUI. That stands for Graphical User Interface Range blocks. And to select these, once you find it, you left click once, you highlight it, and then you keep your left mouse button down, you drag it over here and drop it. So we need 3 of these. And let's select by left clicking and dragging it so we can kind of keep them up here on the first row. You can put them wherever you want. I suggest you put them here. The next thing that we're going to look for is we're going to look for the RTL-SDR block. And we're going to use the one that's under Osmo SDR. Once again, select it with one click, then left click, hold, drag and drop over here on the canvas. And since we're building an FM receiver, we need a way to demodulate that. So let's look for FM demod. And here we go, demodulate. So we're going to select that. We're going to drag and drop it up about here. That's moving on up here. And we're going to need a way to control the volume. And so what we want to select is multiply by a constant. I know that sounds a little strange for a volume control, but that is what we will be using. So we're going to drag and drop. And the last program block that we need to select is an audio sync. And the audio sync is basically going to be the sound card on your PC. So notice in this flow diagram, we have an RTL-SDR source. That's the actual piece of hardware that you should have plugged in right now. And the audio sync, once again, is your PC sound card. So I'm going to start configuring things now, and there's no specific order. You can do it in whatever order you want. But let's begin with the options block. And so I'm going to put my cursor over it, double click. And I'm going to give this thing a title. And you can put your name in here. And that is all we need to do for that block. And so we'll click apply, then we'll click OK. The next thing we're going to do is we're going to double click on the variable. And notice right now it's SAMP rate by default. Let's click here and make this sample underscore rate. And at this point in time, we're going to give this a sample rate of 240,000. So how we will do that is we'll type 240, then we will use the exponent notation. So we will type an E and then a 3. So that's the same as 240,000. So once again, we're going to apply. We're going to say OK. And now we're going to go ahead and configure all three of these range controls. So we're going to double click here, and we're going to we'll call this one RF gain. So for the ID, we're going to use lowercase, no spaces. And then for the label, we can put whatever we want. We will put RF gain. The default value we want to be 50. We want to start at 0 and go to 70. And we will use 1 as a step. Once you have that done, let's click apply, then let's click OK. And the next range control is, we'll call this one the tuner. And so I'm going to use lowercase tuner for the ID, and the labels is what we will be seeing on the user interface. And for a default value, I suggest you do a Google search to find your local FM radio stations. I have done that, and there's a radio station that's 100.3 megahertz. So we're going to type E and 6 since it's megahertz. We're going to start at 89. I'm sorry, we're going to start at 87.9 megahertz. And we are going to stop at 108.1. And once again, that is megahertz. So we'll put an E6 in there. And you can scroll down here with the scroll bar and notice the step. We're going to make the step 100 kilohertz. So we're going to E3. A little later, we'll be talking about GUI hints, but we will leave that blank for now. So we can click apply, we can click OK, and we will now move on to the volume control. So let's open this up, and we're going to call this volume, and we will make the label uppercase V. The default value we want to be 300 E minus 3. We're going to start at 0. We're going to go to 1. And the step is going to be 50 E minus 3. Okay, everything else looks good. Let's click apply and OK. So once again, there's not a particular order in all of this. But what we're going to do next is we're going to open the FM demodulator. And the channel rate is going to be 240 E3. The audio decimation will be 5. The deviation will be 75,000. The audio pass will be 16,000. We could have typed in 16E3 if we chose to do so. The audio stop will be at 20,000. we will leave the gain at 1, and we will leave this particular value at 75 minus 6. And this is for de-emphasis. This is a constant value for the United States. If you're watching this video from a different country, you can look up what your value should be and put that in there. So we will click apply and OK. The next thing we're going to do is, I want you to notice that whenever you see red anywhere in this diagram, and this is called a flow graph, that means that there's some kind of a problem. So I'm going to double click on the RTL-SDR source. And this has several different things we're going to need to fill in. And we're going to begin with sample rate. And let's put the name of our variable, which is called sample, S-A-M-P-L-E. That takes care of that. The channel frequency, we're going to use the variable tuner for that. And we're going to come down here to RF gain, and we're going to use our RF underscore gain. And these are all the things that we need to make sure that we fill out for the time being. So we're going to click apply, we're going to click OK. The next thing that we're going to do is we can connect the source block to the FM demodulator. Well, how do you do that? Well, simply move the cursor inside of the output of the RTL-SDR source, left click, hold down the mouse button, drag it over so your cursor is just inside this blue box here, and release your mouse button. Now, let's do the same thing here between the FM demodulator and multiply constant. So we're going to click here, and we're going to come over here. Uh-oh. Remember, I told you if you see red, that's a problem. Well, what in the world could the problem be? Actually, I changed my mind. Let's do it this way. Whenever you see the orange output, that means the output of the FM demodulator is a floating point number. The output of the SDR and the input to the demodulator are blue, and that means it's a complex number. Once again, these are the I and Q numbers. So let's go ahead and double click on multiply by constant. And we're going to change the output here to, I'm having an issue here because I have screensaver or screen capture software, and these little dialog boxes keep getting in my way. So let's try this again and double click, and this is a problem. So I'm going to stop right now until I can figure this out. Okay, I turned the screen capture off, and I was able to change the data type to float. So notice we have orange to orange, or float to float. The last thing that we need to do is we need to connect the multiply constant block to our audio sync. And notice the audio sync is red, and red means that there are problems. So let's double click this. And what we're going to do is, notice it says there's a problem with sample rate. What we're going to do is we're going to click the drop down, go down and select 48 kilohertz. Release it, then we will say apply and OK. Well, everything looks good now. Let's run our Flowgraph. And there you go. It is working perfectly. We can enlarge the GUI interface, and this is what we see. If you want to make the volume 0, I'm going to now show you how to download the GNU radio files that are contained in my GitHub repository. I will include the link in the video description. But as you can see up here, github.com/pmain/the SDR-Guy. So once you go here, if you already know Git, and that's spelled G-I-T, then you should know how to do this. But I'm assuming that you've never used Git, perhaps never heard of or been to the GitHub site. So what you can do is you can navigate to where you see code here, and let's click on this. And we're going to come down here to the bottom where it says download zip file. And that is downloaded now. And what we're going to do now is we're going to go to our downloads folder, and right here is the zip file that we just downloaded. And I'm going to left click to select, then I'm going to right click and I'm going to extract all. And I'm going to just put this in my downloads folder. And let's do this. And let's extract. And if we open this up, you'll see a README file, and then you'll see 3 GNU radio files. And that's all there is to this step. Next, we're going to start up GNU Radio, and we're going to load 3 GNU radio files that we just downloaded from the GitHub repository. So I'm going to come down to my taskbar, double click, and I'm going to come over to where the folder is. I'm going to click on it. I'm going to go to the downloads folder, and this is the folder that we just extracted from the zip file we downloaded from GitHub. So let's open that. Then our current episode is episode 13, so let's drill down into that. And the first thing we're going to do is load the simple mono FM receiver. So we'll come down here, click on Open, and there we have that. And we're going to come over here, and next we're going to select the mono FM receiver, click Open, and we're going to come and click once again on Open an existing Flowgraph. And we're going to load the stereo version. So select it, click Open. And we can discard this one since no one is using it. And that is that. Lastly, we're going to compare our initial simple FM receiver Flowgraph to two improved designs. But before we do so, as I show the more fully featured or advanced Flowgraphs, we're using GUI hints to place the GUI or graphical user interface elements on the screen. And there's a web page for this. I'll put the link in the description, and we're not going to explain this now, but you can use this to place these GUI widgets where you would desire. Let's go ahead and bring up our GNU radio with the 3 files that we loaded before. And we're going to use as a reference the very first Flowgraph, which is before you, that we created. So one of the things I want to bring to your attention is sample rate. And you can see it's set to 240,000. Well, in the world of SDRs, sample rate is equivalent to bandwidth. And we're going to be using some waterfall widgets. You'll see what that is in a few minutes. And that will allow us to look at the FM radio stations that are broadcasting and show us, within the extra bandwidth that we're going to be picking up. It'll show you other stations if they exist. So in this particular flow diagram, if we pick one of these user interface elements, I'm just going to pick one, and if we scroll down, notice that GUI hints does not have anything in it. It's just empty. So let's compare this to a improved design. So we're going to click on the mono FM receiver. Oh my, we've got plenty of extra things here, don't we? Well, the first thing I want you to notice is that we've increased the sample rate to over 2 million samples per second. So this means we're going to be able to see, a little over 2 megahertz in bandwidth at one time. Again, you'll see what I mean about that later. Now, since we're going with a higher sampling rate, and we still want to get to 48 kilohertz here on the far right side, we're using this thing called a rational resampler. And so it's going to take this 2048 megahertz signal, or I should say sample rate, and it's going to divide it by 3/32. And that will then give us a sampling rate or channel rate of 192 kilohertz. And if we pop this open here, actually we don't need to. We see audio decimation is 4. What that means, take 192,000 divided by 4, and that will be what the output of this is. And that will bring it down to 48 kilohertz. So let's go ahead and start this thing up, and you can see the differences. And as I mentioned there a couple minutes ago, when we clicked on these GUI ranges, we had the GUI hint was blank. Well, on all the GUI elements, I've now added a GUI hint. And you can open these up yourself and have a look. The other thing that I've not mentioned previously, you can pick the kind of widget that you want, and you may want to experiment. So notice there's counter, slider, knob, entry plus slider, or just straight up entry. So you can experiment around with those. So let's go ahead and start this up. I'm going to stop talking, and there's going to be an FM radio station pop up. It's going to be playing music, and I don't want to get into any copyright issues, so I will be basically deleting the audio that you might hear, and then I will be putting alternative audio in there so that we do not have any kind of copyright issues. So let's go ahead and start the flow graph. And how about this? Look at all of our widgets. We've got a waterfall, and the frequency that we're currently tuned to is right here in the middle. And this is what we would expect the spectrum to look like. For those of you that have electronics experience, there's an instrument called an oscilloscope that can show you what the waveforms look like. And the waveform that we see here is the output of the SDR. If we look at the lower right-hand corner, then we see what you would see on a spectrum analyzer. And for those of you that maybe have had some additional mathematics training, this is the FFT, or fast Fourier transform. But these are the three graphical GUI widgets. And then if you'll look here, we've got a tuner, slider, and how you can tune is you can click on this, then you can use your left and right arrow keys on your keyboard to move around here. Notice we have a volume, and if you turn the volume to 0, then essentially behind the scenes, we are making a multiply constant block just above my cursor. It's set to 0. So anything multiplied by 0 is 0, and that would be why we have no sound there. Lastly, we have a squelch. For those of you that may be amateur radio operators, the squelch is used to set the minimum level of signal strength that's required before you can hear it. And so that is another enhancement to this particular design. The last thing that we want to take a look at is the radio frequency gain, RF gain. And we're defaulting to 50. If you have some very strong stations, you might want to lower that. And if you're trying to bring in some very weak stations, then you might want to increase that. So there you have it. This is our improved mono FM receiver. So let's go ahead and shut this down. And let's move to our FM stereo receiver now. Now, many things in this design are the same as before. The big difference here is, notice after this wideband FM receive PLL, notice there's 2 outputs and 2 volume controls. And this is for the 2 stereo signals that will go to our PC sound card. So let's go ahead and start this one up. And once again, we're going to start it up, and we're going to be bringing up commercial radio station. I do not want to get in any copyright trouble, so I will be providing alternative music as you're looking at this. And notice this thing looks the same, the user interface, as the previous one that I showed you, and I've explained what all of this is. So if you have headphones on, you'll hear the stereo, and it sounds quite good. So I know this particular video is much longer than most of them. That said, we've basically created several different building blocks that we'll leverage as we go forward. So you can be looking to see similar flow graphs and videos for AM demodulation. We'll do upper single sideband demodulation and lower sideband, single sideband modulation. And we may also be looking at some various types of digital modulations. So I hope you've enjoyed our session today. Once again, this is Paul, the SDR guy. Thank you so much for watching. I would really appreciate it if you would like the video and subscribe to the channel so you can be aware when new content is released. Thanks again. Have a wonderful day.